Welcome everyone. My name is Weronika Goliszewska and I work in GlobalLogic in Learning and Development Department. And I'm together with Marcin today, who will introduce himself in a moment. But before that, I will tell you a little bit about structure of today's webinar. So as you already saw, you can use a chat to let us know if you have some maybe issues during the webinar. So you already said hi through the chat, so glad to have you here today. So during the webinar, when Marcin will be presenting about introduction to adaptive AUTOSAR, feel free to use Q&A section if you would have any questions. We prepared the time for that to answer them all at the end of today's webinar. So if there will be anything that you would like to ask, please use this space for that. And at the end, we will try to answer your questions. I hope we'll manage to do that, if it will be not too many of them to do. Without further ado, over to you, Marcin. Go to the topic.
So hello to everyone. So my name is Marcin Chamier Gliszczynski. I'm working in GlobalLogic for 1.5 years already in the automotive industry. I'm already 8 years from the beginning, almost busy with AUTOSAR adaptive projects, or before that, shortly using the GENIVI, the CommonAPI, and all the stuff connected with the new platforms for the cars manufacturers. Before involving in software development, we use the CommonAPI, GENIVI CommonAPI, which was later based, we can say, for the AUTOSAR adaptive communication with some IP. Currently, I'm working on developing the platform for the electric cars. So I hope my presentation you will like my presentation. So let's start. So before we go to AUTOSAR adaptive, we have to understand the challenges which face on the automotive industry way. So today's cars has changed a lot from their beginning. So on the beginning, we have 4 wheels, radio. We can say that it just brings us from point to point and played maybe some music as entertainment. Now we go into fully automated cars, full of the infotainment inside the car, and some new features that are still developed and search for the car. No one knows exactly what the role in our life will have the future car. So the same evolution we had already a few years ago with the phones, mobile phones. We just from simple phone now we have computer in hands. Which we have bank accounts, all the applications which support in daily life and even in the work. So now the question is how exactly the car will look like using all those new functionalities and features inside. Will it be, I don't know, maybe our workplace, power bank for our home, for the electric modules? Or this is the open questions. The biggest challenges in the car industry, which is happening right now, is the electrification of the car. So introducing the electric cars gives less benefits for the car manufacturers, as there is less parts, less maintenance. So the car manufacturers are searching now or trying to develop new business model for selling the car. There is all those new functionalities will boost the share of added value by electronics and software in the vehicle to 65% in next 5 years. So there will be the car, so the benefits from selling the car will move from not just selling the hardware car, but to selling the software. So all what we see right now on the market is moving from the hardware selling to software selling. So what we can expect, or what are the trends on the market. So the basic trends are electromobility. So as I pointed out, there is shrink of part range and reduction of hardware complexity. But we introduce much more complex software. We need much more power, computer power, to achieve that. Then we have the automated driving systems, which require high data volume and have a high pressure for safety. This as well introduced much of new software to be produced, algorithms and services or software based on service-oriented architecture. The last trend is mobile services, car-to-X connectivity, update of the system on air or downloading the application. This has to be secured, and and the response from automotive industry or AUTOSAR is introducing the AUTOSAR adaptive platform, which is secure, flexible, can provide the high performance, can support the service-oriented architecture. So the mobile services in the future probably will case that we'll have something like software market, which we have currently in our phones, that we on demand can buy and download new functionality to our car. But how it will look like exactly, we'll see in coming years. There is currently a war, we can say war, between OEMs about war on the platform development. Which platform and the system will be the best for the new cars? So currently, I would say that Tesla is most advanced in this development. Here we can see the development of self-driving cars. So where are we currently? We are currently on level 3. So most of the currently sold cars with those features are on this level. We can see that our car can drive mostly of the good roads with the lines where everything is clean. Continuing growth in the driving assistance systems up to the level of highly automated driving requires advanced sensor consistence of radar, lidar, and various cameras. This means that the vehicle network must support and process large amount of data in short time. The data transport alone requires network architectures that can achieve high data to output with low latency. In addition, the fusion of sensors data requires high performance in vehicle computing systems, which can process complex algorithms with the help of special hardware. So as an example how this goes, so I prepare an example of the car lights. In the past, we have a simple light which was turned on to off on our demand. Currently, with we have a light which reacts on our action in car, so moving around, so it can it's connected to the daily light sensor, so it changes light from the day to the night. If we turn right, left, it's turn on additional lights. In the future, coming future, we'll have individual LEDs in our light that can light the road more accurately to what's needed. The single LED will be turned on basing on the information for the weather, traffic flow, driving cars to us, pedestrians, street lights, everything what can be communicated to our car or sent to our car, so that the light will illuminate the road not only for our car but all other road users, so to increase the safety of the driving. here, what is important that continuous improvement right now is integrated into the car manufacturer. So we have now shorter development cycles. Every new car comes much earlier to the market. We have to develop software much faster. Our car has to communicate with third-party devices, and yeah, those all new features required a lot of network, and yeah, for communicating all this stuff. Even a relatively simple electric car must be able to establish a secure connection with charging station for electrical billing purposes. So all new cars which will be selling will require at least basic stuff on board already. So the response from AUTOSAR is AUTOSAR Adaptive platform. The use of AUTOSAR Adaptive platform does not change the fundamental vehicle architecture. The most noticeable change are the universal use of Ethernet in the vehicle and the related use of the switches. Adaptive platform will not replace classic platform or non-AUTOSAR platforms for IVI or other platforms which are in car. Rather, it will interact with those platforms and external backend system, such as roadside infrastructure, to form an integrated system. So as an example, adaptive platform incorporates some IP, same as already classic platform, and the same method for communication can be used by IVI systems. Yeah, so AUTOSAR Adaptive platform will fulfill the hole between the classic and infotainment platforms. Today's ECU mainly implement functionality that replace our electromechanical system. Software in those deeply embedded ECUs control electrical output signals based on input signals. Future vehicles functions such as high automated driving will introduce highly complex and computing resources demands. So demand software. In those vehicles must fulfill strict integrity and security requirements. So those all will be put together thanks to AUTOSAR Adaptive platform. So what are the differences between the classic and adaptive platform? So the 4 pillars of classic platform. The classic platform is already quite good developed, it's mature, and all those functionalities are well tested on the field already. So it is functional, safe, efficient, and has high performance in real-time capacities. AUTOSAR Adaptive platform will introduce a safe and secure mechanism or system for the applications, for developing the application, running it on the car platform, produce the service-oriented communication, which better consumes the multi-core processors, and will be dynamically able to update the system with the new applications or downloading new functionalities to the car. How it looks from the system perspective. So as we can see, classic platform was based on OSIX, so it was mainly executed from ROM. It was based on signal communication. It was efficient and small, as we can say. Adaptive platform, on the other hand, is based on POSIX. It better uses the memory. It uses better the multi-core environment. It's service-oriented, supports dynamic scheduling and flexible software configuration. Thanks to that, the OEM can distribute development of application to the different developers or teams easily. So As we can see, AUTOSAR Adaptive platform itself will not replace AUTOSAR Classic platform. It will cooperate with AUTOSAR platform and introduce new possibilities for car functionality development. Thanks to the AUTOSAR platform, as I said, we can decouple the development, reuse of the software. So we can write the application once for the one application and reuse it later on the different cars using different platform. Only requirement will be to have AUTOSAR Adaptive platform on place, thanks to the AUTOSAR Adaptive architecture. So let's see what's exactly the adaptive architecture look like. So here a bit of history once again. So we go back. So in the past, we have all the cars, we have the simply connected ECU architecture. We have the ECU connected with the sensors and communication with the signals. Now we have the multiple application software per ECU integrated and it's communicate with the classic platform itself. There will be, or there are already in the development platforms, few ECUs. They mainly separated by domain. There is no definition how the domain has to look like. It could be connected to the separate the car from the front end or parts of the sensors, or maybe a cabin infotainment separated from the sensors. It depends on the architecture of the different platforms. So in the future, we go into the zone architecture. This will be the next level. So we have several ECUs with adaptive platforms and classic platform connected through the Ethernet connection with the central unit, which will be high performing processor and memories for calculating algorithms for AI, autonomous driving, or everything which is processor consuming time needed. So how looks the AUTOSAR Adaptive platform from inside? So as we can see, adaptive platform architecture logical view shows the architecture of the adaptive platform. The adaptive application runs on top of AUTOSAR runtime for adaptive application. So AUTOSAR Adaptive platform, I will show it. So this part here, AUTOSAR Adaptive runtime. In short, it's called ARA. And ARA is split on the two parts. It's the fundamental stuff, which are here. Those are the fundamental interfaces which ARA already provides. So it's the communication channel for communication, mostly based on some IP, IPC, or any other which will be introduced in the future. We have already logging, execution manager inside, health monitoring, logging and tracing, which is currently mostly based on DLT. And then we have the services which can be provided by adaptive platform. The services depends now on the vendor which provides us ARA, so runtime. So which services are available. So from my point of view, or from my point, so I'm mainly busy with the state management right now. Here, diagnosis or other stuff which will be added here in the future is defined in AUTOSAR adaptive architecture. But introduction of this, yeah, will depend on the vendor, and you will, if you be developing the application, you get information which services are available. Now, on this AUTOSAR adaptive runtime, so we have our application which can be run and using those interfaces for their purposes. So how it's look from the hardware level side. So ARA offer mechanisms for ECUs, internal and external communication, network communication, as well access to the basics such as diagnostics and network services management. In addition, the application programmer can directly access a subset of operating system functionalities. So as we can see, adaptive, so thanks to the adaptive platform, we can run separately several applications separated for the car and most important stuff for driving, which will be part of the classic platform. And the communication will go by secure IPC. And adaptive applications is implemented as a last one process in POSIX-based operating system. At runtime, application processes are loaded in their associated virtual address and executed there. So we can see here that our process, adaptive application, which we develop, will run in a container on operating system and will be ruled by hypervisor. So our process will have limited access to the system and the drivers. In most cases, there will be created virtual devices for our process, which will be ruled by operating system. And the devices will be already the devices which we get for our application will have to be well defined, and already thanks to that our application or application which develops is secured from the system. Thanks to that we have this safety-oriented version, so we can see here that applications of adaptive applications can communicate with each other in the AUTOSAR runtime environment, can communicate with the classic platform, but everything goes through the Linux or hypervisor, so the direct access is limited by the system. In summary, for the OS point of view, the adaptive application platform and adaptive application form just a set of processes, each containing one or multiple threads. Are no difference among those processes. It is up to the implementation of adaptive platform to offer a sort of the prioritization. Those processes do interact with each other using the IPC or any other OS functionality available. Note that adaptive application process may not use IPC directly and can only communicate via ARA or called CommonAPI. So as we have the example before with the car lights, so in the past we have the simple switch for car light on off. In the current cars, we have the ARA classic platform for ruling the light, and it was something like that part. In the coming years, we will have additional parts from AUTOSAR Adaptive, which will be connected to AUTOSAR classic platform to exactly say which part of the light LED has to be turned on. So the application, here are several of them, will introduce the service-oriented approach, so that all other users, cars, or other sensors can communicate how the light exactly should be lightening the road. So as we can see in the coming year, there will be a lot of software to be produced to fulfill the new requirements or expectation from the car. So let's look a bit closer to the adaptive platform. So here are the basic characteristics for adaptive platform. So most important is that it's Ethernet-based communication. We'll have a switch inside our car right now for the communicating between ECUs and application, mainly in ECUs. We have multi-core processor, heterogeneous computing to achieve best performance per watt, network on chip. All the applications are using right now C++14, and in the future, for sure, it will be used 17 or newer as the language of choice. Complete model of service-oriented application, system of system that scales well, decouple computing and software probability, inherent full scope virtualization, safety and secure in distributed computing, dynamic management of resources and communication, dynamic behavior limit directly through execution manifest, incremental scalable, changeable after deployment system, agile approach. So we'll be able to provide a car and the functionalities later on through the life cycle of the car. So the car will not be sold on the beginning with already all known functionality. It can be as agile in the project, the car starts to be agile as well. So adaptive platform defines the runtime system architecture. What constitutes a platform and what functionalities and interfaces provide. It is also defines mechanism model that are used in the development of such system. The specification should provide necessary information on developing and system using the platform and what's needed to meet the implement the platform itself. As we can see, the adaptive platform AUTOSAR specification specifies the interface, what was the ARA runtime, and the models. Models are called ARA XMLs. In the model, we just describe our application and the interfaces, public interfaces of our application for service-oriented communication. Toolchain is provided, so the generators, all other stuff are provided by vendor specific. Currently, most known the vendors for the toolchains are Vector and Electrovid. So there are other small or the car manufacturers trying to develop their own, but this is still ongoing. And so how the development will look using the adaptive platform. So we have to define the services. Each adaptive application is defined by the package consisting of executable programmer and manifest files. So, so we have the service interface description, the ARA XML, where we describe our interfaces. Based on them, we can already develop our application and describes the configuration for our application. Thanks to those information, there are sets of generators which generates our package, execution manifest for execution manager, and service interface manifest, which provides us, in case of using CommonAPI communication, JSON file for the CommonAPI communication. There, in the service instance manifest, we have description of the service name, the interface which it provides. Based on that, already we can integrate our application into the developed platform. So making apps is changing a bit. So OM will provide us the services, service definitions, mainly. Based on them, or developers will create applications based on the service manifest, integrator will be able to get our application, and with the already well specified set of configuration, we'll be able to integrate our software on the platform. So here now we will talk how the service-oriented communication works. So as I mentioned, AUTOSAR Adaptive platform currently mainly use the CommonAPI communication for service-oriented communication. So on the beginning, we have the service interface definition, the ARA XML, and we get the generator from the vendor. The generator generates from the ARA XML, provided ARA XML, our services skeleton, so infrastructure for the CommonAPI communication, and same on the client side, the interface for communication with the service. On the developer side, there will be left service to add additional values to the service, and the client to use the specific interfaces. The middle transport layer, which is CommonAPI, will be taken over by our runtime environment. So we will not have to think how to communicate with the client or with the service. We just have to know only the service interface definition file to be able to communicate. So what are the possibilities for communication using the ARA XML? So in the ARA XML, we will define the service, and the service we can provide the communication based on events. So service to clients notifications, methods for request response, so synchronized method calls, and asynchronous calls or fire and get, where we do not expect any response from the service. There's additional fields that are called for the setting and getting values, or be event based. So it's somehow connection between the methods and the events. So as we can see now, we will develop an application using ARA AUTOSAR Adaptive service on the communication. So we have on our one side the server and client. When we start our application, we inform the ARA.com, so our AUTOSAR Adaptive runtime, that we offering service with our name. On client side, client has to find service which it wants to connect. After the connection is established, the client can communicate with the service. So as we can see here is the same stuff. So more deeply into the exact communication. So on the beginning of the application start, we have the offer service line. So all the services which are available in our application should be offered. So we offering the services. The client, when it finds our service, it connects to it, and then it is able to subscribe for the events. After subscription to the events, it will be able to get the event, or without subscription, we will be able automatically to request or get a response from the server for their requests. What allows us the AUTOSAR Adaptive platform? So it allows us, gives us IPC, so CommonAPI for inter-process, and outer-process communication. So we can communicate inside our process or application using the AUTOSAR Adaptive, we can communicate with other applications in our ECU environment using AUTOSAR Adaptive. And as well, through the Aracon, we can communicate with external machines. External machines can be other ECUs in our car or some systems outside the car if we are connected to the network. Service discovery, thanks to all of that, so we can see that AUTOSAR Adaptive Platform will provide us a way for communicating with a lot of ECUs inside one car and external devices in separated environment. The AUTOSAR Adaptive applications services does not have to be the part only of the car. The services can as well can be provided by external application outside the car, and the car can connect to them, for example, to traffic light when they crossing through the city. Okay, so I was a bit too fast, so maybe there are any questions from your side. I would be glad to answer them.
Yes, we have actually 2 questions in our Q&A session. So if you have any and you didn't manage to ask them yet, that's the time. So we have a first question: is classic AUTOSAR going to die soon?
No, yeah, I will turn to the one of the pictures. So yeah, as you can see, yeah, so adaptive platform will not case the classic platform to die. It will still remain in the car, and adaptive platform will just cooperate with the classic platform, because classic platform is mature and well developed in the stuff it does, but it's not. Yeah, their purpose was not the currently known challenges. So as autonomous driving, for example, there is no computer powering and all the stuff needed. So adaptive platform will remain, and classic platform will remain in the car, at least for the next few years. So we can see it on the architectural view. Here, as you can see, there will be still, there we have the AUTOSAR adaptive platform in our car. It can be even on the one platform from perspective of the hardware. So we have several cores for the adaptive platform, and we have saved few or 1-2 cores for adaptive classic platform. So we have at least 2 environments run on the one hardware platform, classic and adaptive. Okay, I think that was, yeah. So,
yeah, I hope that answers the question. So the next one is, what is the meaning of, sorry, it jumped, another question appeared. What is the meaning of heterogeneous setup?
things like that. So I don't know what we are meaning here. So if you are meaning about the setup of the applications, so if we go here to the view for the setup. So thanks to the services, the setup will be defined for each application separately. So thanks to that, so all applications or developed application will be have all individual application will have its own individual configuration setup for the execution manager and the system configuration. Yeah.
Okay, the next one is, I saw ROS in the slides. How much is it tied with the adaptive AUTOSAR?
Once more, which question you mean?
I saw our ROS in the slides. How much is it tied with the adaptive AUTOSAR?
Should I be honest? It's already starting. It's already the slide which you saw. It's the description. Let me go into the slide. So this is only a definition right now of architecture provided by AUTOSAR Adaptive, AUTOSAR itself. Find it. So, so everything, yeah, about the ROS. So it's still under definition, and availability on it on AUTOSAR runtime platform depends on the vendor. So if it is provided or not. So it's hard to say if, no, not all platform has to fulfill this, should fulfill in the future this requirement, but does not have currently.
Okay, thank you very much. And another questions appeared. We have 8 at the moment. So why do we need a hypervisor in the AR platform?
We could say we do not need it. We could live without the hypervisor, but yeah, if we want to provide to fulfill the security of the system, we need hypervisor to separate each application run environment from each other and from the most important safety partition or safety application of the car. So hypervisor, it's a way, a mechanism to fulfill the security requirements for new platform.
And we have another why and another why do we need, and it's about Linux. Why do we need Linux in adaptive platforms?
Yeah, we could use any other system, but I think the Linux is best choice if we can right now easily modify it and adapt to our needs in the system. So it currently is the best system which we have for and it's available in short time which we have to provide the application or the system right now. So if there will be better system, I think it will be used in the future. But right now, I think there is no.
We'll see. Maybe there will be some change in the future. So can you tell us what is the difference between CommonAPI and service discovery?
So it's not differences. So service discovery, so it's only a part. So in this part, if we connect, if we are using CommonAPI for communication between the applications, then we define the server or service provider and client, or multiple clients can use the same service. In the service discovery phase, the server offers the service, so informs the ARA runtime COM environment or runtime COM that the service is available in the system. After the service is available, the ARA COM is informed about the service, it writes it to a part of memory, and client or clients can connect to the service and start to exchange some data or do what they want to do with the service with the interface the service provides.
Okay, and we have 2 questions regarding hardware. I will combine them in one. I hope the people asking them will not mind, do not mind. So it's what hardware resources are needed to run adaptive environment, and what are the minimum system requirements for that? So the processor, memory. Can you tell us more about that? There are any?
So I would say there is not much requirements about the adaptive environment, so it's quite simple runtime. So you only require basic Linux, and you run it or start on it the adaptive runtime environment, and you are already able to use it. So it could be even one core processor, yeah, with, I don't know, limited memory, so that just you run your application, and yeah, and the same from the Linux. So it's not much, but adaptive platform is planned for multi-core usage with a lot of memory. So to dynamically use the hardware resources in the most efficient way. So the plan is that the car processor will have at least 8 cores, probably with 4 gigabytes or even more memory right now. So the system are planned for at least such configuration.
Great, great. So the next question we have is about adaptive platform and classic platform coexistence. Can they do that in one system, ECU?
Yes, as I saw already the highest list before here before. So we can have here example. So this part of all together is one ECU. So we can have the adaptive platform and classic platform on one system. The system should already on the system level, or it should be already separated that part of the resources in the hardware are only for the classic platform, and the rest can be used by adaptive platform. So to the class, so this part should be separated quite much from other.
Thank you very much. And we have another question connected with ECU. Where or in which ECU or components classic platform will be used or applied in 3 architecture you shown?
So as we can see here in the current domain base, so we have ECUs connected with the classic platform, you can say. And yeah, the future zone architecture will be that we will have the ECUs connected with already AUTOSAR classic platform on it, which will be here connected to the service, to the sensors. And all the other ECUs will be connected to each other to the switches and central computing protocol, so the brain of the car.
So that's it. And we have 2 last questions in our Q&A box. So the first one is, if you could explain the service-oriented communication between processes, fire and forget, etc.
So there are, as I said, the XML allows us to define 3 interfaces. So events, methods, and the fields. So events allow us only to communicate from the service to the client. So if the one client or several clients subscribes for the event, which provides through the ARA definition file, then on the service will send an event on any change of the signal which occurs. Then we have the methods. Methods allows us to communicate with the service from the client side. So we have the communication from client to the service with response or without response. So the difference is here that for the event, service communicates with the client. For the methods, client communicates with the service. And the fields are that the clients communicates with the service, so to get some data, and we get a response from the service, or through the events, so service can communicate directly to the client.
Thank you for the explanation. And here is a long one with some explanation beforehand. So since apps are written in C++, an adaptive platform abstracts all the hardware, communication and safety info. So does this mean that data scientists could replace embedded software engineers for adaptive apps development? What do you say?
I would say it's not about the replacing, so because they will have still their place in the car industry. But for sure there will be much more place for data scientists. So yeah, as there will be much more data to be processed right now. So yeah, they will not
So we'll
replace,
definitely,
but there will be a lot need for them, much more than it's today.
we'll definitely have to wait and see how it develops,
Yes,
right, in time,
yes,
how
as
the
well.
market will go. And the last question, AP includes a market. Is this mean the driver can install, uninstall new features provided by OEM?
Yes, exactly. This is what is expected to happen. So in the car will be a market. So the applications, adaptive applications can be introduced later on the platform. So the car can be released without full functionality or with basic functionality. And yeah, in the car will be a market where we can order or download, install, uninstall applications functionality for our car through the network without visiting the service for system update. This will, for sure happens in the coming years.
So thank you very much. It seems that we answered all your questions. So thank you for putting them and being with us today. So we can end a little bit earlier, so you can enjoy the rest of your day. This webinar was recorded, so you can look for it in upcoming days on our YouTube channel, GlobalLogic Poland. And also we encourage you to follow our Facebook profile to hear and get to know about more events that we'll organize. So thank you very much again for being with us today, and see you at the next webinars from GlobalLogic.
Thank you. Thank you a lot. Bye-bye.
Bye-bye.